Hello, today we are going to discuss capacitors and we will learn how to solve tasks with a capacitor. So firstly, let's read the task. A capacitor with capacitance C 2 microfarads is connected to a battery whose EMF is 3.6 volts and internal resistance is R1 ohm. Resistance of the first resistor is 4 ohms and of the second resistor is 7 ohms. And the question is, what charge does the left capacitor plate have? The circuit has a capacitor, so let's review how it works. So there is just a simple rule for a capacitor. When a capacitor is charged, it blocks the current. The first point is charged. Blocks the current. And when a capacitor isn't charged, the current goes through a capacitor. So the second point is isn't charged. So it goes through. So let's get to the task. We see that there is no switch in the circuit. It means that the current goes here for a long period of time and it has charged the capacitor. So now the capacitor blocks the current. So here is no current at all. And the current goes through the internal resistor, through the first resistor and through the second resistor. And the direction of the current is from plus to minus. It means that current goes here, 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 and here, from plus to minus. So the question is, why does the current go from plus to minus? And the answer is simple. It was a historical mistake. In the beginning, people thought that a current is a flow of positive charges. But now we all know that a current is a flow of negative charges or of the electrons. But it is very convenient mostly in all cases, it is very convenient to draw it from plus to minus. According to the Ohm's law, a current through a load resistor so here is a load resistor, here is an internal resistor, here is a battery, so here is the current. So the current through a load resistor is E divided by R plus capital R, the internal resistor and the load resistor. Back to our case. Here we see that resistors are in series. It means that they go one after another. Firstly, the internal resistor, then the first resistor, and then the second resistor. So in our case, the Ohm's law is as follows. The current is E divided by internal resistance plus the first resistor plus the second resistor. Plus is because the resistors are in series. So the voltage of the second resistor is the current multiplied by the resistance of the second resistor. So it is E times R2 divided by R plus R1 plus R2. So here we see that the second resistor is in parallel with this section. So these sections are in parallel, and it means that when the sections are in parallel, they have the same voltage. So the second resistor has the same voltage as here, and we know that the current doesn't go through the third resistor, and it means that the capacitor has the same voltage as the second resistor. So the voltage of the capacitor is the same like the voltage of the second resistor. And we know that the voltage of the second resistor is E times R2 divided by R plus R1 plus R2. Each plate of a capacitor has the same charge, but the difference is that one plate is charged positively while another plate is charged negatively. And in our case, we see that the right plate of the battery is charged positively, and it means that the right plate of a capacitor will also be charged positively, while the left plate of the battery is charged negatively, and it means that the left plate of the capacitor will also be charged negatively. The formula to find the charge of any plate of a capacitor is Q is equals to C times U, where C it is capacitance of a capacitor and U is the voltage of a capacitor. And in our case we have that capacitance is C and the voltage is it is this formula. So it will be C times E times R2 divided by R plus R1 plus R2. So here we have the answer, and let's substitute these numbers here into this expression. And we have that capacitance is 2 microfarad. Micro means 10 raised in the power of minus 6. So it is 2 times 10 raised in the power of minus 6. Then E is 3.6 volts. Then resistance of the second resistor is 7 ohms. 7 divided by 1 plus 4 plus 7 ohms. So lucky for you, I have calculated, and the answer is 4.2 times 10 raised in the power of minus 6 column. The charge is in column. Minus 6 is micro, so it is 4.2 micro column. So this is the answer. Congratulations.